Hey everyone, welcome back to our channel. My name is Link Leocore. I am a data guru and business intelligence veteran of about a decade. If you're new here, don't forget to subscribe and ring the bell so you can stay updated on all things related to tech careers. Today we're going to be jumping into a highly requested topic, the SQL interview process, specifically for the Amazon Business Intelligence Engineer, which I've actually done. Let me help walk you through it. Let's get started. First, let's talk about what an Amazon Business Intelligence Engineer actually does. BI engineers, they play a critical role in analyzing data to drive business decisions. There's obviously going to be a lot of SQL involved. You're going to be writing a lot of SQL code. You're going to be processing a lot of data, working with information. But what you're really focused on is transforming that information, that ability you have to distill insights from data into actionable intelligence, something that the business can make a decision on. And we're talking a lot of different things here. You could be doing trend analysis, gap analysis. You could be identifying different categories of information for their value. You could be developing data visualization dashboards. That's what I did as a business intelligence engineer at AWS. I was the lead QuickSight developer. So I actually created the visualization dashboards that help drive business decisions for about 12 different productivity services apps for the CIO directly. I worked with them on a daily basis. As the engineer, you're going to be working with data scientists, analysts, business leaders, stakeholders, all kinds of different people who are all going to be telling you, we need to know something. And you have at your fingertips access to the information that tells the story that will help them understand that thing that they need to know. So when you're going into the business intelligence engineer role, make sure you remember that this is not just going to be about pulling data and aggregating it and generating tables or perhaps just generating some graphics. You really need to understand the information that you're looking at, what its value is, what its meaning is, so that you can render insights that are going to help drive those business decisions. So to excel in this role, obviously you got to have some strong SQL skills. I mean, that's number one. Amazon looks for candidates who can write complex queries, optimize database performance, handle large data sets. I mean, it's Amazon. They have a lot of data. So breakdown of some key skills that you're going to need. Obviously, basic SQL query stuff, select from, where, join. The typical things that you're going to need to know to be able to throw a query together, but then also those advanced SQL techniques like proficiencies in subqueries, using windowed functions, using CTEs, really having a mastery of your aggregates. And then you're going to need to know some performance tuning as well, because you are working with a large amount of data. You may be running some very complex computations on it as well. So you'll need to know, what good indexing practices are, how to optimize a query, and understanding the execution plans of your queries so that they run efficiently. You don't want needless loops or, endless functions that aren't completely necessary to derive the product you're trying to create. And finally, some data modeling that's going to be really important. Normalization of databases, the ability to construct ER diagrams, basic database design principles. I mean, if you're here, you probably already understand how a relational database works, but do you understand why it works that way? And do you understand how to put one together yourself to suit the needs of a product that you're designing? The visualization dashboard that I mentioned earlier was a composition of 12 different productivity services apps within the Amazon AWS suite. And I had to make sure that I understood the value and the importance and the meaning of all of the different data points across those 12 different products, because they were all collecting different kinds of data. They weren't all the same kind of app. And then I had to understand how to model a database that would allow me to bring the information for all 12 of those apps together and compute them in the same way so that I could run them across similar metrics. So that's going to be important as well. So what we'll do is we'll take a look at some key skills. We'll focus on some things to know during your interview, and we'll get you off to the races. So let's go over some common interview questions. These are like knowledge check type things that are designed to test your understanding of just the basic concepts of SQL. Not everybody necessarily knows every one of these. Some of them are obvious and some of them are given, and a lot of the times you just plain know these already inherently, but you don't actually know the details of them necessarily because you've just kind of worked with them in the past. You've never had to actually build them or start from scratch or explain what they are. The ability to do that is going to be something you'll need to have in an interview. So let's look at a couple of these. So to start with, how do you handle nulls in SQL? Now, let's remember something here. So you can see I've inserted some values into a 2-field table, and there's a null for ID number 3 in the value field. It's an actual null. It's not the word null. A null is the absence of data. All right, it doesn't mean 1 or 0 as opposed to 1. It doesn't mean true or false. It means the absence of information. We actually don't have any data on this. If we were to average out a column of integers and some of them were nulls, the nulls would be skipped by our aggregate function because there's no value to count. It's not a 0 that's going to bring down the average. It's a null, meaning don't count this one. If we have 12 records and 2 of them contain nulls, our average is going to be out of 10 values, not out of 12 where 2 of them are 0. It's a null. It's an absence of information. So we have a null here. There's a couple of different functions here. So to start with, we'll look at the coalesce. The coalesce says, go ahead and try to use the value, but if there's no value, if there's a null, do something else. And in this case, we're going to write the word empty. So we'll run that real quick, and we can see that our null here was changed to empty while all of our other non-null values stayed the same. So that's pretty basic. The isNull function, which I'm going to uncomment here so you can see it, but we're not actually going to use it because it's not present, because it's not necessary in Postgres 9.4, is very similar. It says if this value is null, then do something else. Right, and as you can see, this isn't going to work because isNull isn't a function in 9.4. Now, you might be asking, well, what's the difference between isNull and coalesce? Coalesce allows you to put in a comma-separated list of values that you can try one and after another. If it's not field 1, then go to field 2. If that's a null, then go to field 3. If that's a null, then go to field 4. If that's not a null, cool, use it, right? It'll take the first not null value from a list of values. And then the final one is null if. This is a little bit different. This basically says if the first parameter is null, or rather, I'm sorry, it basically says return null for this entire field, which I've just called null if the 2 arguments are equal. So if our val argument is equal to 4, it's going to null that out. And as you can see, these are all left the same. 3 is still a null because that's what it was originally. 4 was originally 4, so it got turned into a null. Now, there's a lot of different situations where you may want to use this. So, for example, you may want to say, I've got zeros in my data and I don't want those to bring down the average. So I'm going to say null if val is equal to 0. That way I get a null and it doesn't affect my average. I mean, typically if a 0 was recorded for a metric, that's important to include in the average, but perhaps you have some reason that you need to actually do. There can be other items, like if there are specific non-allowed strings that you want to null out or something like that, you may have cause for that as well. So that's nulls. And remember, like I said, it is the absence of data. There is no information to discuss about. Next, another interview question that you get is about keys, primary keys and foreign keys. Okay, and these are important for a relational table. Primary key is a unique identifier for a row. It cannot appear more than once in a table. Depending on how the key is identified, you can bend those rules a little bit, but typically what will happen is the primary key will be a unique value to identify that row. That's important. It cannot be null. There must be something there, because if it is null, then you could have broken links, but you could also have multiple null, because null is the absence of data. So it's not checked for uniqueness. So you could have multiple rows that have a null, and then it would become impossible to differentiate them from other rows. And that's the important part of the primary key, is differentiating one row from another based on whatever that key is. And it is also immutable. Write that down. 2 M's. Good word to know. It means it cannot change. It does not get changed by anything. Create the primary key when you create the row. That primary key stays that primary key so long as that row exists. Doesn't get used again either in the case of deleting a row. That's important to know. The foreign key then, as you can see over here, when you have a related table, the foreign key says the row in this table, student marks, where a student got 65, is related to the student details table where the primary key is 2041. So Tom got a 65 in his Java course. Now, the foreign key can be repeated. What if Tom takes multiple attempts at that course? What if Tom takes multiple attempts at a single test within that course, or takes multiple tests within the same course? What if Tom takes multiple courses? That ID number 2041 is going to show up in student marks quite a bit for all the different tests that he takes each time he gets a mark. And that's fine. But importantly, this is how we relate a value, a record in the related table, student marks, back to the primary table, student details. And obviously we would typically have a lot more information about this too, like how else can we link this, for which, depending on your database design, and we can go into some advanced data modeling techniques down the road, but for which course was this mark given, right? That would be an important piece of information to have. For which test was this mark given? For which assignment? On which date? Which attempt number is this? So those could all be important, but every single one of those records would still have the foreign key in the ID field of 2041 to relate them back to Tom taking the Java course, okay? So that's important. So a foreign key basically uniquely identifies the row in the other table. The purpose of the foreign key being to enforce that referential integrity, that's another great phrase to write down, between two tables. So the foreign key value must match an existing value in the referenced table's primary key column. Otherwise, it's not going to work. It's not going to refer to any. For those of you who know a little bit of advanced stuff here, you'll know that with some table design will have cascading keys that say when a key is updated, make sure all of the related foreign keys also get updated to the correct new value as well. So that is handling nulls, what the difference between nulls are, what the definition of a null is, different ways that you can query with a null, what is a primary key, what is a foreign key. Let's look at execution plans. Now, don't get too scared by this graphic. Basically, what this is showing you is when you run your SQL query, what's it going to do? And you can see there's a lot of things here. The select, that costs nothing, right? There's going to be a hash match from a right outer join to a different table, and that's going to take 18% of your query's usage. It's going to, all these different statistics. You'll learn to read one of these depending on which environment you happen to be working within. This screenshot is based out of SQL Server Management Studio, the Microsoft product for working with Transact SQL. There's another one that I've got here that is out of a totally different tool. This is a third-party tool. But essentially what you want to understand is, where is your query the most expensive? What part of your query is taking the most processing, the most memory, the most usage on the server in order to compute? This one we can see very obviously. It's the table spool and the segment, right? So we would want to go back to those sections of our code and identify, is there a different way that we could potentially run this operation? Maybe something that's less resource intensive, maybe calling up something into memory beforehand or using temporary tables or what have you. But with both of these, the concept is to identify where is your query becoming the most expensive. Now, we're not going to spend a whole lot of time on this video actually telling you how to prune and tune your queries. That'll come later. The important thing to understand is, how do I get to a query explanation? And I said it that way because you can simply put the word explain at the beginning of your select statement to do something like this, so that I can see where my query is costing processing power, resources, and that way I can tune and optimize my query. We've all had those situations where we've run a query and it's just gone on for 3 or 4 minutes, and we're like, well, what is taking so long? You want to go into the query optimizer, look in here and look for the information about where your bottlenecks are, what's taking the most processing. And by the way, if you heard me say that 3 or 4 minutes was taking too long and you were astounded by that figure, if you thought that was too low because your queries run 20 or 30 minutes, open this up and start looking at them. If you thought that was too high because your queries run in 10 or 30 seconds, well, great job. But you're going to be working with really large data sets very soon. So you are going to be encountering these kinds of things here. So that's just a couple of the kinds of questions that you're going to get asked in an interview. And these are to challenge your basic understanding of how the technology works. It's one thing to know how to drive. It's another thing to know how to drive safely, right? Or within the laws of your region. Those are the kinds of things that you want to be prepared for. So go ahead and rewind and watch that again if you want to make sure you're prepared for that. There's plenty of great information available out there, but those are going to be some of the first things you'll ask. So we'll jump into some actual interview scenario type situations in just a second here, and make sure that you're ready for doing some actual coding. So let's talk about the actual interview portion here. Amazon Business Intelligence Engineer, they want to make sure you know what you're talking about, and part of that is going to be a live coding session. Not every company, not every interview does a coding session, but Amazon does. And they'll typically share a link to you so that you can log in and type code onto a screen while they watch. Not watch you, but watch what you're writing, watch the code. A couple of things to know about this process, though. You're going to go into it with a very basic explanation, okay? They're going to give you some example tables that will just be there on screen in plain text, typically. And they'll have some data in them so you can see what you're working with. You're not going to have full documentation of the data governance information about what the data means or how to use it. You're not going to have all of that because these are going to be pretty basic questions that just test your ability to solve a problem, not your knowledge of an existing system. The other thing is, don't be afraid to ask questions while you're working on this. It is their data. It's their information. They've given it to you to work with. And if you don't know it, ask a question about it. What does this field mean? When this column title says average, what's it an average of? Over what? Over what time span? Don't be afraid to ask those questions. And finally, and most importantly, don't be afraid to mess up. It's okay to type in the wrong answer, execute the query and say, you know what, that actually doesn't look good. Let me tweak this a little bit. They don't really care how long it takes you to do it. They don't really care if you get it wrong the first couple of times. They care if you can get to the right answer. They will train you to work faster and work smarter and work more efficiently if they need to. But if you can solve the problem, that's the big aspect here. Now, some other things to just think about as you're doing this, and you're going to see me do this on screen in just a minute here, is understand your requirements. First of all, your requirements are the contract. That's the work that you're doing, and you will do that work to the letter. If the requirements are not clear enough, ask questions. Ask what they mean by this. What exactly did you want from this? I can't tell you how many times I've gone to somebody and I've delivered their report and they said, well, what about these other fields that I wanted? And I said, you never mentioned you wanted those fields, so I didn't include them. Be specific. Ask questions. That's your contract. Another thing is explain your thought process. Detail why you've done something, which is exactly what you're going to see me do in just a minute here. What caused you to use that particular function or write things in that specific order? Why did you do it that way? Demonstrating that you understand the tools that you're using is leaps and bounds more important than being able to use them, right? So, without further ado, let's take a look at a couple of questions here. So we've got this one here, salary by department, and right away they're giving us the schema. This is what the table is going to look like, the columns and the types, and then here's some example data of what's in there. This is our requirement right here. Write a query to find the average salary by department, round the result to 2 decimal places. Well, this should be fairly straightforward. They've even got an example output of what they expect it to look like here. So let's get started. We have a table here, employees. So we're going to select from employee, which I never type correctly the first time I type it. Usually I add an extra K in there or something, just where my fingers are on the home row. So what are we doing? We're finding the average salary by department, and we know that we want the department. That's important. And this is going to be an aggregate. We're averaging. So we're going to be grouping this all by the department. So we want to get the average salary by department. We will say group by department. And if we run this, we should get something that looks fairly similar to our output here. What did we forget? We forgot to round to the nearest 2 digits. So we'll just add that in. Run that. Oh, got an extra comma in there. See, and that's okay. Make a tiny little mistake and just fix it. Nobody is going to fault you for that. So that looks accurate. And if we actually check our answer, well, it looks like it's encountering some, oh, you know what? I didn't title it the right thing. See, it wants this average salary title. So we'll go that. Boom, now we're correct. That was a piece of cake. And that's a fairly straightforward one here, but did you notice how I explained that since we're going to be doing an average, we're going to be doing an aggregate, which means we need to group by our category field, however that ends up being. In this case, it was department. So I explained what I was doing. This is a fairly simple one. Let's take a look at another one. Employees who started before their manager. Again, we've got some schema information so we know what we're looking at. The HR team asks you to write a query to find all the employees who started before their manager. Please order by employee start date in ascending order. Okay, I think we're not going to end up using the building table. This must be in there for another question that uses the same employee table again later for a different solution. So, oh, and we got our example output here of what we think we're going to be getting. So let's try this. So we need to find employees by their manager. What is this going to be testing? Right? So we've got employee IDs and then we've got manager IDs. This is a point where you can stop and ask a question and say, when an employee has a manager ID, is that manager ID self-referencing the employee ID column? And they would tell you yes. And now you would understand how to perform your join, and they would be very impressed that you were thorough instead of making an assumption. So what we'll do is we'll select from employee, there's the K, employee E. We will get, what fields do they want? They want employee ID, and they want first name, and they want last name, and they want start date, and they want some other fields here. So we're going to need to perform our join to get those other fields. We're going to say left join employee back onto itself, this time aliased as M on m.employee ID equals e.manager ID. Now notice that I was very careful there, and I understood that when I'm calling the employee table to get my managers, it's the manager's employee ID that I want, and I want to tie that to the employee's manager ID. Some people get this backwards and then they don't understand why their queries look, okay? And being able to explain that out loud is going to help you out here. Now we can grab our other fields here where we can say, well, I guess we could just do e manager ID, or we could do m employee ID as manager ID, and we'll do m start date as manager start date. Let's run that and just see what we get. Okay, so we've got some expected information here. Simple join. We didn't do anything to this query. All we did was join on it. We didn't filter it. We didn't do anything to it. So let's filter it now, because who started before their manager. So we want to say where the employee start date is before the manager start date, right? Now we're cooking with gasoline, right? We've got the information that we want here. Looks like it's a nice solid match. Just to cover our bases, because they will notice if you miss this, it says please order by employee start date in ascending order. So we will do that just in case. And we're correct. So just be thorough, right? Look at these very carefully, understand what you're trying to do. These were not that complicated. The ones you're faced with are not going to be that complicated. I'll explain a few more in a minute here. So don't be too afraid of them. They're just testing that you have the basic ability to do this. Let's do one more for the heck of it. So startups with no sales. This should be interesting. Your portfolio manager wants to know which startups need attention and asks you to write a query to show the startups in the US that have no sales yet. So we've got some orders that have been placed for various item IDs in certain quantities, and then we have a catalog of locations and product groups. So the first question that I would ask is, what are the startups? And it looks like, since we're zeroing in on some product groups here, that's probably the startup. So we'll start with that. And we know we're going to need to do a join because we're going to have to look at that orders table too. So from catalog, what do we want to get? We want to get the item ID, the product ID, product group, and the location. I suppose I probably could have just done c.star, so we'll just do that. So we're going to get that have no sales yet. So let's left join the orders on that item ID is what it looks like it's going to be. Yeah, on o.item ID equals c.item ID. And, you know, just for the heck of it, we'll put in o.star there so we can take a look at what our results are. Oh, we'll go back to explicitly naming all of our fields here. And so we'll say o.order ID. So we're pulling in all fields now. Item ID does not exist. Oh, I misspelled it here that whole time. See? It's okay to make mistakes. They won't say anything. They'll just sit back and let you mess up. But once you recognize it and get it, they'll be fine. It's not going to make you fail the interview. The ability to identify where your problem is something they want to see. They want to see you mess up. They want to see how you fix it. So we've got everything here. So we want to say, we want to get product group E because it has null orders. So we can just really simply say, and we don't even need these fields anymore. We can just really simply say where o.order ID is null. And we should get, yeah, exactly the answer that they're wanting. Perfect. Okay. Now, a couple of things that I wanted to mention about this one, the reason why I like this example is because, there's going to be some situations where no sales yet, right? So there will be dates in here. So you may have to work with dates that say when the sales happen or no sales by a certain point. So you'll have to work with those dates. And there may also be some situations where you have orders that were for zero quantity, or they were for a certain quantity, but they then got returned or refunded or didn't count. And you're going to need to ask those questions about your business requirements and say, do you want me to include these? Do you want me to include voided orders? Do you want me to include orders for zero quantity? What does zero quantity mean? Is that an erroneous value, or should I count that? So make sure you're thorough when you're looking at those kinds of things. When I did my Amazon Business Intelligence Engineer interviews, I had to do some simple problems like this, just very basic stuff. One of the examples that comes to mind was write a query to identify how many unique flights there are between a variety of different airports at different times. That one took about a half an hour to really type through and get the whole thing together. Another one was simple employee type stuff, like what's the average salary per department for employees who have been there over a certain number of years or were hired before their manager. So they'll throw a couple of additional conditions at you. But again, going back to what I mentioned, don't be afraid to mess up. They like to see that you can correct yourself, because that means they don't have to help you all the time. It means you're not going to be submitting code that doesn't work, that they have to constantly go back and review and fix and figure out what went wrong, because you're going to catch it yourself before you submit it. Make sure you understand your requirements very, very, very thoroughly, right? You need to know what information you're supposed to be collecting, how you're supposed to be computing it, and although it's not always included in the requirements process, I always like to do a little interview with my stakeholder and say, what are your goals here? What are you trying to accomplish? What are you hoping to discover? Or what question do you have? Not just what query do you want me to write, but what knowledge are you trying to obtain? Because maybe I'll discover something while I'm working with. I've been on a lot of teams where developers worked like that, and they were able to surface insights that the business didn't know that it had. And I've been on a lot of teams that were just writing plain code specifically according to exactly what the requirements were. And that's never fun. These are a couple of on-screen things that you might have to do. The Big Tech Interviews platform has hundreds of these, and I've done them all for fun. I just went through them all. Definitely make use of that platform, practice up, get into I'll put it on screen again, get into the SQL Fiddle type situation. That's what this website is SQL Fiddle or DB Fiddle, and just work with practice databases if you don't have one deployed on your own. Practice, practice, practice. That's what you're gonna need to do. We'll talk about that again in just a second. All right, so preparation tips, right? Like I said, practice regularly. You're going to be doing this on the job every single day. You might as well do it when you're not on the job every single day, so that you're ready to do it on the job every single day. That just makes sense. Your fundamentals. What are indexes? What is a relational database? What are keys? How do nulls work, right? These kinds of things will make or break you in certain scenarios, so make sure you understand those. Also, go out and understand the business of the company you want to work for. Go out and understand, what is Amazon? What are they doing? What are they trying to accomplish? What do their products do? How do those serve their customers? And think like a business person. What would an Amazon executive want to know about how that thing's doing, besides just how much money it's making them, right? And do some mock interviews, practice with friends, get people to interview you. It doesn't even have to be somebody who's technically minded. I mean, they may not be able to run you through a code exercise, but you don't need that. You've got VTI to do that. It could just be somebody who asks you the kinds of questions that helps prepare you for any interview, but maybe they can specifically target it based on, role playing as an Amazon executive. So definitely get out there, practice, prepare. There's no amount of preparation that's going to be too much for one of these things, but also take it easy. Take a deep breath. Okay, the Amazon interview process is very thorough. It's a couple of interviews, and they're very long, not laboriously long. They're just thorough. They like to get to know you. They like to understand who you are and how you are going to be a contributing component on their team. And just be yourself, I mean, you don't want to pretend to be this person during the interview and then get on the job and have to continue pretending to be that person in order to perform, right? So make sure you keep those things in mind. Well, that's a wrap on our guide to acing the SQL interview process for the Amazon Business Intelligence Engineer role. If you found the video helpful, definitely give it a thumbs up. share it with your friends. Leave a comment if there's any questions or topics that you want to see gone over at some point in the future. Good luck with the interview preparation, and I'll see you in the next video. Hey, don't forget to check out our other videos and subscribe to the channel to get more tech career tips and tutorials. Have fun out there.